Welcome to my channel. Today, let us discuss about the gradient of the scale. Okay, already we have discussed about the delta operator, and while discussing the delta operator, we have said delta operator is used to define the gradient of the scale, right? And initially, let us define the gradient of the scalar. The gradient of the scalar is nothing but the scalar field V is a vector that represents both magnitude and direction of the maximum space rate of increase of V. Okay, which represents both magnitude and the direction. Okay, so the below given figure shows the gradient of the scalar, in which the gradient of the scalar is defined by the potential difference between the 2 points P1 and P2. Okay, the gradient can be defined by evaluating the difference in the field dV, P1 and P2, where B1, B2, P3 are the contours of V and is constant. What we have discussed already is that the figure which provides the potential difference between the 2 points, this 2 point potential difference is evaluated and which is given in the name of gradient. The gradient of the gradient can be obtained by evaluating in the difference of dV between the points P1 and P2, where V1, V2, V3 are the contours and which V is the constant. And by means of calculus, the gradient can be the application extended towards the EMT, calculus extended towards the EMT. From calculus, the dV, the change in the difference of between the two fields is given by dou v by dou x into dx plus dou v by dou y into dy plus dou v by dou z into dz. Right? X and x, y, z coordinates. And this partial differential derivative is given by dou b by dou x ax plus dou b by dou y ay plus dou v by dou z into az into dx ax plus dy az plus dz az. In general, the gradient expression can be provided by the gradient is denoted by the letter G, and G is equal to dou v by dou x into ax plus dou v by dou y into ay plus dou v by dou z into az. And the potential difference is given by dv, which is equal to G into dl, right? And this G into dl is given by this figure. Okay, these two potential differences provides a gradient of the field, and from these 2 points we get the term G dv into dl. We are taking a small elemental differential displacement, so I am representing this by dv, which is equal to G into dl. And this dl, which makes an angle theta, this theta is given by the cosine of angle between the 2 points. So we are writing the differential term as G cos theta into dl. dv by dl, which is equal to G cos theta. So as said already, dl is the differential displacement from P1 and P2, and theta is the angle between the G and dl. Okay, and next is the gradient will be maximum when dv by dl is equal to maximum. That means we know that dv by dl, which is equal to G cos theta. When theta is equal to 0, the dv by dl will be maximum. Why? Because cos theta is unity, we know. So G will be maximum when dv by dl will be maximum when theta is equal to 0. While substituting theta here, we have the maximum value of dv by dl, and dl in direction of G for maximum is given by the expression dv by dl, which is maximum, which is equal to dv by dn, and dn is the normal derivative. In general, the gradient expression v can be written as v is equal to del v. Okay, this del v is nothing but dou v by dou x into ax plus dou v by dou y into ay plus dou v by dou z into ax. Okay, so the gradient of the scalar, which is obtained by the means of potential difference between the 2 points, and the gradient is nothing but a vector which has both the direction and the magnitude. The gradient can be expressed as v, which is equal to del into v, and this gradient expression in general is written as del v, which is equal to dou v by dou x into ax plus dou v by dou y into ay plus dou v by dou az into az. Okay, and the equivalent cylindrical coordinate expressions is given as del v, which is equal to dou v by dou rho a rho plus 1 by rho dou v by dou pi a pi plus dou v by dou z into az. And the spherical coordinate expressions is del v, which is equal to dou v by dou r into ar plus 1 by r dou v by dou theta into a theta plus 1 by r theta dou v by dou pi into a pi. So, cylindrical coordinate, which is expressed in rho, pi and z. Spherical coordinate, which is expressed in r, theta and pi. So, with these three notations, we express the terms del v as in terms of rho, pi, z, and also in terms of r, theta and pi. So, generally speaking, gradient is nothing but an vector quantity. It can be expressed in the expression E is equal to del V. Okay. So, let us once again discuss the del operator, another application in the next session. If you like this video, like, share and subscribe. Thank you.